series of rolling terraces that have a lot of depressions on them. And you notice the lakes, how the lakes are all oriented in one direction. And I did throw another line down here, that dashed line, just to represent that as you go down the rivers, if you ever float the rivers, you get to a point where there's a transition and you leave the strictly glacial area, and now you're into an area that's a mix of glacial activity and tidal influence. The tides coming up, depositing silts. The glaciers here that affect us are all alpine glaciers. They all start high in the mountains, in little valleys. They slowly progress forward, and eventually they combine with other glaciers. And it just becomes one massive lobe going downstream. And we look here, you can see the amount of debris that the glaciers are eroding off the valley sidewalls and bottoms, and also carrying along with them, depositing that downstream. And the black lines, the striations that you see in the glaciers, are simply where two glacial lobes came together. And all the debris at the side of each one joined together. So each one of those lines represent two or more individual glaciers coming together and forming into one massive glacier. The thing is, when we look at the glacial history here, it's not what we see today. This isn't the valley, but this is what the valley looked like thousands of years ago. Only the highest mountain peaks sticking out of the ice. And I've got here 5 major glacial periods that have occurred in the last 200,000 years. There's probably more, but these are the only ones we have evidence for, because glaciers, each new glacial period, when massive ice movement comes down, it tends to wipe out everything that was there before. But the two that are most important, I think, for us is one, like the oldest that we can recognize, Matanuska glaciation, because the remnants of that glacier, the materials that they can date back and identify to that glaciation, occur at the top of Mount Susitna. That gives us a benchmark. Mount Susitna is about 4,400 feet above sea level, the elevation. Pioneer Peak is 6,400 feet above sea level. That means we've had ice through this area approximately 75 to 80% up the sides of Pioneer Peak. Gives you an idea of how much we were buried here, or this area was buried. The other glacial period is the Naptown Glaciation, the last major glacial period. In these glacial periods, it wasn't that ice came and the ice left. The ice was pulsing forward and backwards, but it was dominantly burying everything in the area. The Naptown, the maximum extent was about 22,000 years ago. And it's important because as glaciers move down the valley systems, they destroy everything in their path and move it, rearrange it, but then as they leave, they rebuild the valley with what comes out of the glacier. So we live here in Palmer and the surrounding areas, we live on the landscapes that were built by the Naptown Glaciation. This just gives a kind of an idea of how much of North America was covered during the Naptown Glaciation. And most of Canada, most of northern United States was buried by the Laurentide ice sheet, came out of Hudson Bay. But everything in the west came out of what they call the Cordilleran ice sheet, which was all alpine glaciers. They all came out of the high mountains. And we can look a little closer at Alaska during the Naptown Glaciation. And this period was also called the Late Wisconsin Glaciation, but it's in Alaska the term Naptown is used. And the white areas represent the extent of the ice in Alaska. You can see most of the Brooks Range was covered, the Woodhills Mountains out in southwest Alaska, and then everything in the Alaska Range and coming south, and including parts of the Aleutian and southeast. What's interesting to note is this island right here, just below the Alaska Range, that was never glaciated. That is the Copper River Basin. And the Copper River Basin is surrounded by, what's it, Talkeetna Mountains, the Alaska Range, the Wrangell Mountains, and the Chugach Range. As these glaciers came out of the mountains, they kind of coalesced and dammed the whole area. And so we had a huge lake in there that essentially covered all of the Copper River Basin, Lake Atna. And it's one of the few areas in Alaska you can find clay, real clay and soil in it, because it's all of the fines that settled down out of Lake Atna like you would find in any lake. The other thing, and this picture doesn't show, but I think it's interesting, is during this time, sea levels were about 400 feet lower. And so what we look at is the coast of Alaska that we know of extended way out. And this was the period of the Bering Land Bridge, because between Alaska and Russia, the sea levels were low enough that we connected. This picture here will start up at the head of the valley. This is on what I call Blueberry Knob. Some people call it the Alaskan Knob. It's off Alaskan Road, right across the Glen Highway from Gunsight Mountain. We're looking toward Glen Allen. And what you can see is basically tundra. Tundra underlain by permafrost, very shallow drainages. This is just a finger of the Copper River Basin as we move out into the former area where Lake Atna was. So what's interesting, I don't have a picture from the other side of the knob, but you see these very shallow drainages here. Everything's wet in here. The permafrost is holding the water up. But right about where they get to the knob, and you can start to see the cut here, all of a sudden, they just tremendously downcut. And if we were looking off the other side of Blueberry Knob, you can drive up there or hike up. You look off the other side, and all of a sudden you just see these huge canyons. These little streams just become huge canyons, all become tributaries of the Matanuska River drainage. This is where, when the ice around Lake Atna thawed, where you have the outlets, and this was one of the outburst outlets, where portions of Lake Atna plunged down the Matanuska River Valley. And unfortunately, a lot of people have studied the glacial effects. There isn't a lot of study on what Lake Atna did. And there's starting to be more and more where people are recognizing deposits over around Wasilla and other areas, sand deposits, and that they could have been from the outburst of Lake Atna. But if you're out and about and you get a chance, go to the top of Blueberry Knob and just, you're on that transition looking more into a tundra region, the former locale of Lake Atna, or you look the other way and you're looking down into the glacial valley. We're lucky here because we have the opportunity to go see active glaciers. The Knik Glacier, Matanuska Glacier, several of the other ones in the state are easy access. And up in Matanuska Glacier, you can see all of the features that you're going to see in any alpine glacier. The front of the glacier, you see a lot of crevassing because energy is being released. The pressure that the ice is under is being released at the front. So lots of crevasses. You've got the glacial rivers that are so typical. They're called glacial-fluvial rivers, but they're all formed and developed by glacial activity. You always have a lake right in front of the glacier, a meltwater lake, your proglacial lakes. The most interesting thing to me is you look at the sides of the glacier, all the debris that the ice has pushed to the sides but still carrying. And all of this in here is still part of the glacier. It's dominated by ice, but there's just so much debris you don't see it. If you look up at the mountain slopes, you kind of see the rugged, rocky slopes coming down, and then all of a sudden, there's a transition line right through here where the slopes just subtly change. They get a little bit gentler, a little bit more rounded, and you can trace that all the way around here, and especially over on this side. That represents how high the ice was at one time. That's sort of where the glacier elevation, where it stopped, everything above it was undisturbed rock, bedrock. Everything below it was eroded by the glaciers, and then that glacial till was smeared on the sides. This is the oldest picture that I've been able to find of Matanuska Glacier. It was taken in 1898 on the Edwin Glen expedition up the Matanuska River. The fellow who took it was W.G. Mendenhall, and I think most people are familiar with the last name. USGS 1898. And you can see the extent of the glacier coming down. You can see the debris in here, and all of this in here, down in this area, is all ice, rock material mixed together. Now let's look at this about 125 years later. In fact, let me back up a minute to do that. Look at this notch right here. And now 125 years later, I think I took this 2 years ago. There is that same notch. And you can see how much that the ice has receded and moved back. We're in a period of glacial retreat. What is also fascinating looking at this, notice the change. Look at that valley down there. All of as the ice receded, all of that debris, you slowly have vegetation succession. And you're seeing the floodplains with willows on them. You get up a little higher on the terraces, you're starting to see forest succession taking place, all part of this natural change cycle. I want to pause a minute and just define two terms because they get used, a lot of times they're used interchangeably, but they're two separate things. One is glacial till. That's all the material that a glacier actually, well, it's actually in contact with the ice. The ice is pushing it, it's smearing it along the sides, it's underneath the glacier. It's under a lot of pressure, but it's the ice moving it. Glacial till tends to be fairly compact because of the pressure. It can be difficult to dig in, water doesn't move through it easily. But then we have glacial outwash. This is all material that's contained within the ice, loose material that as a glacier recedes, is constantly being washed out at the front of the glacier. But it's not under any pressure, so it tends to be very loose sands and gravels. It's easy to dig in, water runs right through it, and it also forms the base of the landscapes that most of us live on. A lot of the photos that I'm going to show tonight are older, and part of that is the reason is when I was actually working, you had the opportunity to take them. I don't have the opportunity to fly around anymore. But keep in mind as you're watching these, you're familiar with the valley you live in now. It also gives you an idea of how much we have changed culturally, the growth and the development. This photo is looking upriver towards Sutton, and you can see the active river channels down here. This is taken in the fall, the river's low, so we only see one or two main channels. You can see that constant, little channels all throughout. But look over here and we have an area that's a little bit higher now. You're starting to get vegetation on it. You move a little bit higher over here and now you're starting to get forest vegetation. And behind it, you can just start climbing these steps. And each one, as you get up there, you're a little bit older in geologic time. And in terms of forest succession, you're getting into more mature forests. The biggest thing is, all of that is the former floodplain of the Matanuska River. That river meandered back and forth in its braided channel all the way across those terraces. What I want to do here is show a very generalized cross-section of the valley. And I'm going to emphasize generalized. I mean, there's too much detail to go into. But picture this massive lobe of ice coming down the valley, eroding the sides of the mountains, eroding the valley floor, carving this huge valley trench, and then it starts to retreat. The glacier moves back, releasing huge amounts of water, carrying all this glacial outwash, and it fills the valley. And you have your braided streams on top, braided river channels, and you have these huge, massive ice blocks that calved off the front of the glacier and either became stranded there or they might have rafted downstream and become stranded. They become buried by the outwash. And as time progresses, rivers do what they always do, they downcut. And so, say this is the Matanuska River Valley, we're downcutting through that alluvium, and we have a lot of water flowing out of the glacier due to whatever the climate is at that time, a lot of downcutting. And so our river is lower, we see a new sort of drainage or valley forming, our ice blocks are melting out, and we're starting to get these huge depressions in the landscape. Over time, glaciers, and they don't necessarily have to be advancing or retreating, but if there's periods of high flow, volumes of water, they're carving down like a rivers do. If it's a period of low flow, they start aggrading. They start losing all of that sand and gravel, and the river bed starts to build up. And we see that in the Matanuska River channels where it keeps building up in the channel, and all of a sudden the river goes, wait a minute, this is getting too high, I need to find a low point. And it shifts and forms new channels so it meanders all over the floodplain. And what we see here is that valley, new valley we cut in the alluvium, or in the outwash, excuse me, that new valley has now filled with more recent outwash. It cut down and it graded again, a couple more ice blocks were rafted in. And this process just keeps continuing. And this is what we have in the Matanuska Valley drainage, and especially what we see here around Palmer, is the stepwise sequence where the river deposited glacial till, downcut, started grading again, filled it in again, and we end up with this staircase sort of topography. And a great illustration, this is looking up towards Sutton, looking down on Clark Wolverine Road. A lot of this has changed up there, but with the farm fields that were there in the 80s, look at the surface of those farm fields. It's the exact same topography you see down here on the active floodplain. And yet I don't know how high that bluff is, I'm gonna say 100 feet. You're way up there, and what it shows is that the river at one time, this was all the floodplain of the Matanuska River. The other thing I'll point out, I said those cross sections were very generalized. You can see here where the Matanuska River, it narrows down and goes through a canyon of rock walls. That's because the glaciers, as they came down, they didn't uniformly scour out the floor of the valley. They hit resistant rock and went around it. And so you have a lot of these ridges of bedrock sticking up. Long Lake up the highway is a great example of that. It sits in a trough that was carved by the glaciers, resistant rock. The glaciers would, retreated, and Long Lake filled with water. As we come down our terraces, this is about the lowest terrace where the city of Palmer is located. And locally, it's got a local name, the Palmer Terrace. You can see the airport here. Again, I can't remember when, 2011. So even in the last 12 years, how much this has changed. This is the Springer Loop area. But it's very nearly level, outwash plain, a lot of little lakes filled with water, and you see little depressions in here, all these melting ice blocks. Off to the right of the yellow line is the active floodplain. This was taken in early spring, so there's still ice. But as you come up, you go up about a 30-40 foot bluff onto the Palmer Terrace. You go across the terrace and get over here to the Noisy Goose restaurant, and right behind it, what happens? Say you're on Moore Road. You go up another bluff, probably it's a little steeper, maybe 50, 60 feet. You've gone from the river floodplain, the active floodplain, to the Palmer Terrace, to the next highest terrace, but they're all glacial outwash terraces. And just pause here a minute, visualize a little bit of a road trip. You went up to Hatcher Pass for the day, you're coming back, coming on the Palmer Fishhook Road, you get to the Glen Highway and you turn right, head toward Palmer. What happens? Immediately, you begin to go downhill until you get to the road that goes into the Cedar Hill subdivision. You level off. And then you go a little further until you hit Marsh Road, and you drop again fairly steeply. You've got a big, there's a red retaining wall on your right. And that levels out when you get down to about Woods and Wire Music. You go on that level surface until you get to Scott Road. As soon as you pass Scott Road, plunge down again, and you're down on the Palmer Terrace. So you've just come down this whole series of outwash terraces into town. You're coming down in time, basically, from the oldest down to the youngest. They're just different ages of outwash. Well, let's switch a little and talk about the rivers. And it's all linked with the glaciers. This is taken on the Butte side of the river across from Palmer. I think this was late August. And this area here, the water's gone down some, but there was very active erosion in here. The highway department went in and actually buried boulders and revetments in there to protect the bike path and the old Glen Highway. But this was one of the main channels for many years. Lots of active erosion on this side. And then about, it was 3 summers ago, right in the middle of the summer, in a very short period, this went dry. And the main channel shifted, I should say the main channel shifted, and it moved to the center of the floodplain, and a very high volume channel moved all the way over to the bluff against the Palmer Airport. Just in a matter of probably a week or two. Just simply because this side was a grading, and so the river shifted because it wanted to go to the low point. This is a picture this summer taken in late August, and I know there's others that can correct me, but I've been up here a little over 40 years. It was the first time I remember seeing the Matanuska River bank full, where there was water all the way from the bluff of the terrace on the Palmer side, all the way over to the Butte side. All of these gravel bars out here, there's some debris, trees that hung up on them, but most of the gravel bars you couldn't see. It looked like one solid river going across. And I got curious and trying to figure out what was going on here, but at the same time, I do a lot of hiking along the Mac River up in Glacier View. There's a section of the river that is, it's narrower than down here, but in August, the mean high water table is always about 8 feet below the terrace that I walk on. And so I was up here in August, and the river's down about 8 feet looking over the embankment. I was up there the next weekend, basically 7 days later, the river was down about 8 feet below the terrace. But I would say a third of the terrace that I used to walk on was gone, completely gone. A lot of debris in the river channel. The river was following a different course, and across the surface of the remaining terrace, there was a lot of fine silt that had been spread, and right away to me that says, in 1 week's time, the already high river suddenly shot up at least 8 feet, tore out most of the terrace, not most, but a lot of it, deposited silt, and then went right back down. And this was at the same time that we saw this effect down near Palmer. I got curious because I'm thinking, just like what we had in Juneau, a glacial outburst. You know, a lake or small deposit of water up at the glacier first, but no, excuse me, no information in the news. USGS didn't have anything recorded on it. So I looked a little deeper. The stream gauge that's at the bridge going from Palmer to the Butte, that USGS has a stream gauge there. In August, at that time, the water had been running about 8.5 feet where it measures. And on August 27th and 8th this summer, that suddenly shot up almost 3.5 to 4 feet. Doesn't sound like a lot, but that's a lot of water to spread out over a huge area. And then it dropped again. Again, no information on the news, so I looked at the local weather data. On August 26th, during the state fair, we had one day where there was a short duration storm come in from Prince William Sound, dumped almost 2 inches of water, it's recorded in Palmer, and then it was gone. And at the same time, I looked at some informal data sites up in the top peak of the mountains. They had 4 to 5 inches. So we had one very short duration, intense storm, came in, shut the river up, changed the whole floodplain configuration, 50 miles upstream. And down here, I do a lot of hiking here. I'm far in the Springer Loop. I got trails down there on the terraces. A lot of them are gone. Acres of those terraces and all the trees and vegetation are gone just because of this one short-term event. And now that the water has dropped for the winter, you go down there and it's like looking at a gravel pit. It's just, again, acres of channels that are now abandoned that will fill again this spring, and we'll see what the river does next year. But again, constant change. The last thing that's part of these glacial impacts is wind deposits. And they have a fancy name, aeolian deposits, which stands for wind. Loess is the actual deposit, which is very fine sand and silt. But we're up in Hatcher Pass, and we're looking out over the valley and seeing what I always call the gray wall. The wind is blowing, the silt's being eroded off the floodplains, but at the same time, it's being deposited downstream. We're taking from one area and we're building in another. And if we were to actually go down on the floodplain, get out in this, you can see what the source is. The winds are coming across all of these bare floodplain areas. And think about it, when do we have the most, I'm not going to say the most wind, but when do we have the most silt blowing in the air?
Spring.
Springtime. In the winter, this ground is frozen, and a lot of it is covered with snow, so the wind can't pick up these particles. Later in the summer, we have a lot of glacial melt, there's more water bearing some or covering some of these areas, and later in the summer it's also, we have more rainfall, and that keeps the particles from moving. But in the springtime, the glaciers haven't, the water from the glacier melt hasn't come up yet. The snow and the ice is gone, and it's the driest time of the year in this area. Very little rainfall from basically late April until you get to the 1st of July. And so this stuff is just very loose, sand and silt, nothing holding it in place. You get a low pressure cell here, and you have high pressure in the interior, or Prince William Sound comes down the Matanuska River Valley or down the Knik River Valley and just carries all of this silt off. Again, like I say, yes, it's eroding here, and it's humorous because I know a couple of agencies many years ago that thought they were going to go out there and plant trees and stop. Those trees are gone. But it's a natural process. It's change. It's moving from here. It's moving downstream. It's building more soil downstream.
Isn't it why we have our open farmland?
Yes.
What was
This,
that?
she was asking, isn't this why we have our local farmland? And yes, and this is typical soil here in the lower valley. I like to call them two-story soils because underneath we have the glacial outwash, and it's soil. And at about 80 centimeters there, there's a fairly abrupt break. Above it is all very fine sand and silt, no rock fragments. And jump ahead here. Well, this slide here, just going back to our cross section, just shows how those terraces across here, they're all outwash, but they're all now capped by this silt cap, this loess layer. It varies in thickness by how far you are from the river and what the wind tunnels are. But over by Sherrod School, 14 to 16 feet thick of this silt. It's all coming down the Matanuska and up the bluff. You get down on Springer Loop, it's about 6 feet thick. You get over to the experiment farm, it's about 30 inches thick. It just all depends how close you are to the river. But you ask about agriculture, let's take a look again out across Springer Loop. Old picture because This isn't what it looks like today. There's probably more homes and farm fields out there. But we can look at what the land uses are and how sort of the geologic history has made it suitable for those land uses. Here's our soil. We've got the glacial outwash underneath, very loose gravels, drains rapidly. On top, we've got the silt layer, holds a lot of water, has a lot of nutrients, and we end up with agriculture. The Matanuska Valley, Fairbanks area, and Delta Junction, historically and currently, are the most productive agricultural areas in the state. The Palmer area and Delta Junction have identical geologic history. They're both, the fields and everything are out on glacial outwash plains where glaciers came out of the mountains and all the silts blowing up out of the rivers. And so you have this very productive soil on top, and then because you have the sand and gravel underneath it's loose, you have great drainage. So once the frost goes out, you can see it driving around the farm fields just in a matter of days, ponded water, and then all of a sudden it's gone. Frost went out and it just drained down through the outwash. What we also see though across this area is the gravel mining, resource extraction. And regardless of what your feelings are about it, it makes sense here. Because look down here in the corner at our soil again, that lust mantle on top isn't that thick. It's overburdened. They strip it off. Underneath, you've got very well sorted sands and gravels that are easily screened, and you got a market in Anchorage. And you got a level surface so you don't have to do much, and your excavating is simple. And it explains why we see so much of the gravel extraction. And then we look at probably our newest industry, subdivisions and the associated commercial development. A lot of it is due to our infrastructure here and economics. But on the other hand, look at our soils, nearly level surface. A contractor coming in does not have to do much land leveling at all. You got this lust material on top, which is not suited for building homes because it holds a lot of water. It turns to soup basically when it's wet. But you can easily strip it off. And underneath, sand and gravel, you don't even have to haul it in. It's here. You got a very stable, well-drained material to put your foundations or footers on. And if you're smart, that lust that you stripped off, you stockpile it so that you can regrade and put that in for your landscaping or gardens. And I always find this humorous because I've gone through some subdivisions where I see them scrape it off and then they truck it out and they sell it to someone else. And then the homeowner about a year later is tired of living in a gravel plain and pays someone else to haul it back. So 3 very different land uses. And again, I'm taking, I consider economics and infrastructure, but again, they wouldn't be here without the geologic history of the valley. They wouldn't make sense here. I'm going to jump out to the Matanuska Greenbelt, the area extending from Matanuska Lake all the way up to Crevasse Moraine. And all of a sudden, our whole idea of terraces goes out the window. Now we're looking at an area that it just doesn't make sense. Sort of I always call it the spaghetti bowl of these ridges and valleys, and then we have all these lakes in here. And we'll talk about the lakes first. Well, I've got this slide here. Exact same area. It's a LiDAR image that strips off the vegetation. I threw it in only because it really makes these features stand out, how unique they are. Remember we talked about these ice blocks falling off the front of the glacier, calving off, getting stranded, getting buried by glacial outwash, pouring out of the glacier as it melts. And they form what are called kettle holes when they melt. When the ice melts, you get large depressions. If a kettle hole, if it doesn't have water, if it extends down and there's either springs or direct contact with the water table and it fills, it's a kettle lake. They don't have any inflow or outflow. It's all a glacial depression from ice blocks melting, contacting the water table. And that's what all the lakes are out in the Matanuska Greenbelt. And it gives you an idea these depressions, the kettle holes. This is on the farm field. I think they call it the ABC field. You got your bike and running path on the left there. But you see these islands out in the farm field. And then you get closer and you see what they are. They're these big depressions that they can't farm. These are all kettle holes where ice blocks have melted out. Going back to the Greenbelt, Matanuska Lake, Kepler Lake, Johnson Lake, all of these lakes in here are kettle lakes, where massive ice blocks, I mean, you look at those lakes, Matanuska Lake, it had to be one big ice block. Massive ice blocks melted out, and if you're out there hiking and look at these lakes, they don't have an inflow or an outflow. There's not a stream feeding them. They're just big depressions that contact the water table, and that's why there's water there. And then doesn't show up well in here, but then there's the numerous depressions and little ponds all over the area. What about, as I say, the spaghetti bowl, these hills and ridges? And geologists tend to argue that there's two different causes. Personally, I think they're both relevant, and they've occurred out here, but one is, we're looking across the front of a glacier, not here in the valley, but it's large crevasses, and look where the wind-blown materials accumulate in the valleys, slowly filling those valleys up with debris. Imagine this, if this was the front of a glacier and another glacier was releasing tremendous volumes of outwash, washing over the top of this. It would fill all of these valleys in here, and then when the ice melts, what would you have? Gravel hills and valleys. The same thing you have out in the Greenbelt. And if you look at the published geologic literature for the lower valley, there's real strong evidence that as the Naptown glaciation waned and everything was melting back, when the Knik lobe and the Matanuska lobe finally separated into two separate unique glaciers, the Knik lobe stagnated. And they've got enough data from deposits that it stagnated, the front of it stagnated, didn't move forward or back, right in the area of the Greenbelt. The Matanuska Glacier, the lobe, continued to move back, continued to melt back, releasing all of this outwash. Where did it go? Right over the tops of these crevasses. And then eventually, as the ice melted out, left the hills and valleys. The other explanation, and as I say, I think both of these are present out there, is what they call eskers. And all of your glaciers have streams and rivers flowing underneath, and especially at the front of a glacier. Water moving, water carries sediment, sediment falls out of the water and accumulates at the bottom and builds up, and then eventually the glacier melts and retreats, and what do we have left? These hills and valleys. And this was a picture took in the early 80s down at Portage Glacier when it started to rapidly retreat and move back. And this is an esker that was left behind, melted out. And just looking at it, you can just see that this is an example of the features you see out in the Greenbelt. So I think both of those, the crevasse moraines and the eskers, are what you see out there when you suddenly get into this area of no terraces, but all of these hills and valleys. A little bit of an anomaly when we look out up toward Knik Glacier. We're out on this outwash plain, and all of a sudden we have what we call a hill or a butte, probably be a mountain in some areas of the United States in 448. Bodenberg Butte. Why is it there? Why didn't the glacier destroy it and subsequently bury it with outwash? Prior to the glaciation, most of the mountain ranges here, the bottoms where the valley is now, is granitics. They had a lot of voids in them. You had magma coming up from molten earth coming up, never got to the surface, filled the voids, hardened into rocks like rhyolite, which are extremely hard. And so as the glaciers came down and started carving out the valley, they would hit this rhyolite, or these very resistant rock layers, They work away at it. And they try, but eventually they would just simply override the top. And you get a very distinctive landform. It's called a roche-nez. It's a French term that means sheepback. Now, you're gonna have to go talk to somebody from France. I have no idea how that relates. But they have a very distinctive topography or shape. You look upstream, this would be, say, looking up toward Knik Glacier, Matanuska. And in the case of the butte, looking up toward Knik. The ice is coming down, it's trying to carve and erode this away. It's hitting very resistant material, so it climbs up over the top. But it's very abrasive on this side. It gets to the top, and as it moves over, it loses energy. It's not as abrasive, but as it falls and moves over, it from frost action will pluck out boulders from the sides. And you get a very distinctive shape. So now we look at Bodenberg Butte. We look at the upstream side pointing toward Knik Glacier, a relatively, oops, wrong button. Relatively gentle slope going up, kind of level across the top, and then a steep slope on the downstream side. Bodenberg Butte is a classic roche-nez, where the ice came down, carved the granitics out, put the rhyolite out, and over the top and shaped it. If you look around, Burnt Butte, which is off, or would be a little bit to the northwest, it's the exact same thing, has the exact same shape. There's also a butte out where the small one out where the old and the New Glen highways come together down along the Matanuska River. All three of these are just where there were rhyolite outcrops. I'd like to end this with just talking about where can you go out and see some of these features in the valley. One of my favorite places, easy access, is the Greenbelt, the Matanuska Greenbelt. This is on the outwash terrace above Matanuska Lake. You're on an outwash terrace. You're looking across the lake. The lake is there because at one time there was a massive ice block here that melded out and made contact with the water table and filled it. So you're on an outwash terrace. You're looking across this kettle hole. You're looking over at Pioneer Peak, and right about where the shrub line ends on the mountainside is where you see that subtle change in slope. Above it, you've got the sort of jagged, bare rock weathering away, and then all of a sudden it gets a little bit rounded and a little gentler slope, and that's about the elevation that ice was at one time here in the valley. All of this area buried. It's interesting to note, it's sort of a generalization, but it's also right about where the shrub line is. And the reason for that is that alders, which most of that is, can grow in glacial till, which is smeared along the front of the mountains. Above that is pretty much highly fractured and weathered rock. Alder won't grow in it. And so a lot of times, you go down to Cooper Landing and you see it real pronounced on the mountainside. You see right where that break is also where the shrub line is, where the alder ceases to grow. We jump a little closer looking across, and you've got a classic U-shaped valley. Glaciers, as they carve out valleys, they don't downcut like a stream, they carve out this bowl shape or U shape. And we can see here that a side tributary or glacier came out of here, joined the Knik Lobe, carved out that U shape, and then subsequently, when the ice melted, you still have a stream through there, and so now we're back to a traditional valley where we have stream down cutting through it. Standing at the same spot above Matanuska Lake, I'm looking off to the east, and there's the tip of Bodenberg Butte, sort of pointing the way upstream to Knik Glacier. I turn around and I face the other direction, and I'm looking out at Mount Susitna, which is our benchmark, giving us an idea of how high the glacial ice was in here. It's interesting, too, that Mount Susitna is a roche-nez, a formation of highly resistant bedrock, and the direction of it was mainly carved by lobes coming down the Susitna River Valley. Just looking at, or throwing out some ideas, other great glacial landform viewpoints around here. Matanuska Glacier State Recreation Area is at mile 101 of the Glen Highway, just before you get up to Long Rifle Lodge. They've got this fabulous hiking trail. It's about a mile on the bluff of the river with interpretive signs explaining all of the glacial processes that we get to see up here, because you're looking down at the glacier. You're looking at everything that's active. Then come down to Matanuska Lake State Resource Area, and now you're looking at all of the landforms that were created by that glacier, not so much when it came down, but when it retreated back and left all the glacial outwash and terraces. Another one is the Glen Highway Overlook, just northeast of Palmer Fishhook Road. Driving up the Glen, you go past Palmer Fishhook, and on the right is a big parking area, some social trails up to the bluff. You can look up toward the Matanuska Glacier. You can't see it, but you see the Knik Glacier. You see the terraces. You can see the transition line on the mountainsides. I think one of the most interesting things there is go up there a couple times a year and look at the river channel. And then you can see change. Some of it is seasonal change, some of it is due to, like this summer, a very short-term event, but that channel changes, the channels themselves are multiple. They change in location, they change in volume. One side of the river to the other side of the river, they may cover most of the floodplain, they may hardly cover it. Just constant change. And now, what I consider probably the best local landmark to see glacial viewpoints, Bodenberg Butte. Climb the butte, you're climbing a Rochemont Neck. You get to the top of the butte, you look out, you see Burnt Butte, it looks exactly the same. You can see the butte, the unnamed butte down by the highway, and you look at the two buttes, and both of them, the tails are pointing right up to Knik Glacier. You can see the path the glacier followed. While you're on top, you're looking down on the farm fields, a lot of subdivisions now, but you're looking down on lands that are developed on these glacial outwash surfaces, these terraces. If you're lucky enough to be up there on a windy day, you can feel the sand, you can taste it, you can get covered with it. And quite honestly, I find it's interesting to live in a place where we have so many active processes going on. Had a class up here, where I went out with a class many years ago from Wisconsin, a university class, and these students were thrilled because everything they knew about glaciers and in their textbooks were the landforms left by glaciers. And then they had to figure out and study what processes occurred. They came up here and it was like, I can see both. I can go out and experience both. When you're on top of the butte, you can see the striations where the glacier tried to carve through the bedrock. You can see these grooves in that. The other thing is take a look at the soil on top. It's all wind-blown silt. And when you look at it, if you get a big cross-section, there's bands, light and dark bands. And if we had a period that was dry with a lot of wind blowing, it deposited light-colored material. If we got into a period when the wind wasn't blowing much, and things were stable, vegetation established, incorporated a lot of organic matter and left a dark layer, and then dried out again, a lot of wind. And this layering effect, I can't remember offhand, it's been a couple of years since I've been up there. Probably in some of the steepest cuts, you're going to see at least 5 or 6 of these alternating layers of light and dark that just give you an indication of change over time. How the climate changed, the net effect when you have the wind blowing, and the result that you can see. And the last thing, this is a personal for me, I find it easier to hike the rivers anymore than I do the mountains. Get out on the river floodplains and the river terraces and hike those, and all around Palmer, and you will see the most active change. Every day, you'll see change every day, you'll see it through the seasons, you'll see events like this summer, and while you're out there, if you get near one of these steep bluffs and terraces, or if you're up in the mountains and you're near a steep talus slope, get out of the way and sit there for a little while and listen. And as you're sitting there, just pay attention. You hear rock falling, constantly rock falling. Geologic change, it's occurring constantly, reshaping everything. But to put a little time span on it, I read an article a couple of weeks ago, it really hit me, because the author made this comment. He said, you're out hiking on the trail and you kick a rock out of the way. Or you could be down listening to a rock fall off of one of these terraces. But that rock was here long before we ever got here. And that rock is going to be here long after we're gone.